Hi, this is Miss Park, and this video is about solving word problems that have to do with setting up an algebraic expression and solving an equation. So just to introduce how we start with the word problems, every word problem is going to involve a variable. Okay, so we'll have a variable used to replace something in the relationship that we're trying to find. Okay, and then we'll be given information in the word problem, excuse me, where we can set up an equation and solve for the variable. So maybe it's a formula that we can use, or maybe something else that's given in the word of the problem. So let's just, before we do solving any equations, let's just have a look at setting up the questions using algebra. So for example, write an expression or an equation for the following phrases. So I'm going to take an English phrase and convert it into an algebraic statement. Okay, and in these examples, they're giving us the variables to use. So for example, number one, John, and we're going to use J for John, is 2 years younger than me. We'll use M for me. Okay, so J is going to represent John's age, and M is going to represent my age. And we're going to do this in order of the sentence. So J, so I'm going to put a J, and then there's the word is. So in math, what does is mean, right? If I was going to convert that into a symbol for an equation. So is an equal sign, right? So J equals, John is 2 years younger than me. So how are we going to do this? 2 years younger than me. So if I'm 10 years old, then John is 10 minus 2. If I'm 20 years old, then John is 20 minus 2. Okay, so if I'm M years old, then John is going to be M minus 2. Okay, not to be confused with 2 minus M, even though it says 2 years younger than me, the 2 is coming first. If you did 2 minus M and you put my age in, you'll get a negative age for John. Okay, so that's the first example. So let's keep going and see how it feels. This jacket, we'll call it X, costs twice as much money as a shirt, which we'll call Y. So X is going to be the cost of the jacket, costs twice as much. So the cost of the jacket equals twice as much money as a cost of a shirt. So that would be 2 times the cost of the shirt. Okay, and we're not going to use times because it looks like X. You can just go 2Y. Okay, the age difference between you and me is 5. So the age difference between you and me is 5. We don't know who's older, you or me. So it could be that if you take your age minus my age, you get 5. That's the age difference. Or it could be that my age minus your age is 5. We don't know. We would have to decide who's the older person. Okay, the area of a rectangle is equal to its length multiplied by its width. So let's just go area of the rectangle. They're saying use capital A. Okay, it is equal to, so there's your is equal to, or in other words is, length multiplied by width. Now notice they used capital A for area. That's usually we use capital A, but for L they used a capital L, and for width they used a lowercase w. That's because lowercase l looks like a 1. So avoid it. Avoid using L as a variable unless you're going to make it capital or you're going to make it like curly. Okay, the sum of 2 consecutive numbers is 65, and the first number is X. So consecutive means one after the other. One after the other. So like 4, 5, 11, 12, 21, 22. So if the first one is going to be X, the first number is X, what is going to be the second number? Right? The second number is consecutive. It means it's the one that comes next. So if the first number is 11, the second number should be 11 plus 1. If the first number is 100, the second number should be 100 plus 1. So the second number, I'm just going to write over here, the second number is X plus 1. Okay, first number is x, the second one has to be x plus 1. So the sum of two consecutive numbers is 65. It means if I take x plus the number after it, the sum, you can put it in brackets if you want, equals 65. Next one, speed is distance divided by time. So speed is, that's equals, distance divided by time. Just make sure that that looks like equals there. Okay, a number, little x, is 4 more than twice a smaller number. I'm going to take out this of, there's no of. Okay, so a number x is 4 more than twice a smaller number n. So it's 4 more than. So I'm going to start with this twice the smaller number n and add 4 to it. Okay, twice the smaller number n and another 4, that gives me x. Okay, and the last one, the total cost C of renting a car is a $40 base fee and $20 per day. So we've seen these ones before, that's a linear relation. So the total cost C of renting a car is $40 base fee and, so and is plus $20 per day. So per means multiply. If you know the number of days, you multiply the number of days by 20. So plus 20 little d. Okay, so that's your introduction to setting up the word problem. So let's do a couple word problems as a sample. Okay, there's on this page, there's words that come up in word problems. So sum is adding, difference is subtracting, product multiply, quotient is what you get when you divide. Consecutive is one after the other, so like 10, 11, 12, let's say. Even, like 20, 22. Odd would be like 21, 23. Integer, you should know. Area and perimeter. So you might have like shapes. They might give you some shapes of triangles or squares, whatever. Finance, cost is how much something costs. Expense is how much you have to pay. Hourly rate, you know. Revenue is how much you earn. Okay, so these are in dollars. Okay, and then it says then bottom, avoid some of these variables. That's because they look like other things. The reason they say avoid x and y is because they're kind of meaningless. Like x and y, they have no meaning. We try to find variables that remind us of what they're representing. So, for example, cost would be a C, D would be days would be a D, time would be T, like that. Okay, so x and y is kind of meaningless. You won't see me using x and y much in word problems. Okay, I'm just going to skip ahead to some examples. I'm going to go to this one here. So one number is 3 times another number. If the sum of the numbers is 36, determine the two numbers. So if you want, you can pause the video here just to reread this sentence and try the question. One number is 3 times another number. If the sum of the numbers is 36, determine the two numbers. Okay, please pause if you want to think about this. Okay, so I'm going to work on this question with you. Okay, the first thing we're going to need is we're going to need a variable. Okay, and there is a very particular way that we write solutions to word problems in grade 9. The first thing is to introduce the variable with something called a let statement. Okay, when we take a variable, so for example, for number, what's a good variable for number? Okay, I would say n, not x. Try not to use x. So n for number, and we say let n represent the smaller number. And I'm going to say the smaller number because they're both numbers and we don't want to make them both n. But I know that one of the numbers is 3 times the other one. So if one of them is n, if the smaller one is n, then what's the bigger one going to be? It's going to be 3 times n. So I'm going to say here, therefore, 3n represents the larger number. Okay, so this first sentence goes with the let statement. So I'm going to write here, I'm going to underline this in blue. Okay, And now I'm going to change my pen color to something else, and I'm going to deal with the second sentence. And the second sentence is going to give us an equation. If the sum of the numbers is 36, determine the two numbers. Okay, so the sum of the number is 36, so that means the first number is n, the second one is 3n. If I add them up, I get 36. Okay, and it's asking us to find the two numbers. So this is an equation. We know how to solve this. N plus 3n, collect the like terms, you get 4n. 4n is 36, so we can divide both sides by 4 to figure out what n is. And we get n is equal to 9. Okay, so we've now solved the equation, but we haven't answered the question. So I'm going to change color again. Say green. Okay, and now here's the part where we have to answer the equation. Determine the two numbers. All right, so therefore, the first number is 9. I know this. And the second number is 3 times 9, which is 27. Okay, and you'll notice that my answer here in the green goes right back to my let statement. Right, the first number is n and the second number is 3n. So it's not enough to solve the equation and stop. You need to give your answer because it's asking us for two numbers. So we have to give an answer that is two numbers. Okay, so that's our first example. Let's do one more example. One number is 4 more than twice another number. If both numbers are positive and the difference between the numbers is 27, determine the numbers. Okay, I'm going to go back to my blue. Okay, and we're going to write a let statement. Now, we know we need a variable, but what's the variable going to be? So the way you're going to know what the variable is going to represent is look at the end of the question for where's the part that asks you what the question is. What are they asking for? They're asking for the numbers. So if they're asking for the numbers, then we need a variable to represent numbers. So we'll use n. Now it says one number is 4 more than twice another number. So again, we have a situation where there's a bigger one and a smaller one. So let n represent the smaller number. And so therefore, what's going to be the bigger one? So 4 more than twice the first number. So 2n plus 4 represent the larger number. Now, do you notice I used a therefore and not a second let? Can you think why that is? Why I didn't write let 2n plus 4 represent the larger number? Right? The reason is we use let when we're bringing in a variable we've never seen before. Right? I'm going to take this variable n and let it represent something. Once it represents something, I don't need another let because 2n plus 4 is not new. It's still n. If I had a second variable, which is what we have in grade 10, we have two variables, then we have a second let statement for the new variable. But there's only one variable, so there's only one let. Now, both numbers are positive, so I don't know what to do with that right now, so let's see how it works out. The difference between the numbers is 27. Difference you get when you take the larger minus the smaller. So I'm going to get 2n, sorry, I'm going to change the color so that I'm going to change the color so that we are consistent with the other problem. So one number is 4 more than twice the other number. That was my let statement. Okay, and I'm going to change the color and write the equation. If both numbers are positive and the difference between the numbers is 27. So let's write this. The difference between the numbers is 27. So larger number minus the smaller number is 27. So collecting the like terms, I have a 2n minus n. So 2n minus 1n gives me 1n plus 4 equals 27. I want to subtract 4 from both sides. And so n is equal to 23. Right? Now, is that my final answer? N is 23? No, of course not. I have to go back and see what did they want. They said determine the numbers. Well, the numbers come from the let statement. So back to the let statement. So determine the numbers. I'll make it green now. Okay. Therefore, so the first number is 23. Okay. And then you could write this whichever way you want. You can go 2 times 23 plus 4 equals, what is that? That's 46 plus 4, 50. Therefore, the second number is 50. You can even have a final concluding statement. Therefore, the numbers are 23 and 50. Okay, and that's how we do the word problems. So please try them, practice. The answers are in the booklet, and good luck. Thanks for watching.